All right, let's get started. So I'm just jumping in for someone else who couldn't make it. So I have actually one slide of content, and the rest we'll just live code, and feel free to just jump in and speak, and let's make this interactive a little bit. Right, and rate the session. And yeah, you know me, you may know me from these projects. Oh, there's a second slide, actually. Simple type safety for the unusual things. Exactly. So this is really about 3 ideas and how to basically infuse types into these areas where we normally don't use types or don't use types to this extent. One is configuration. Like, I suppose a lot of you use something like Typesafe config or something like this to read your configuration. And I would like to propose a way that I consider simpler, safer, easier to reason about, easier to learn, requiring less work. And then also how to call processes and interfaces in or REST services or something in a type-safe way. And the other thing is basically how to expose the types you have in Scala into other situations. So you can call into Scala in a type-safe, or I guess in a type-driven way. OK. So that's the slide. So now we'll just get to coding. I've hacked up this like pseudocode application which does almost nothing, which has a main method that calls some HTTP server to listen, right? Just a regular web app. And this HTTP server has a listen method that takes some, I guess, some library. Some library HTTP server, which we just assume is we have imported as a dependency, and then let's assume this could be HTTP4S, could be Spray or something like that. We have some create method that we give a bunch of routes, and I don't know. Let's say that's a bunch of case statements that is routes. That's what HTTP4S does. OK, fine. That's OK. And then it binds itself to a port, and we need to get this port from somewhere, right? And we probably want this port and the IP address or something to be different between our production environment and development environment. And one way to do this is we can have like a config object. Let's say config. And yeah, from there we can just get it. So let's look into config. We have an environment val here, which reads a environment variable, environment. And well, if it's not there, I think it's null, right? And then if it's null, then we just assume development. Otherwise, we can provide one. So in production, we could say, oh, it's production. And then we have a config factory. Like, I don't know if Typesafe config works exactly this way, but I remember it being like vaguely like this. So you have this config factory. You load one configuration file. In this case, we take whatever the environment is we got here, which somebody may have provided calling it, or which is development otherwise, and then we load the config file. And then we have a resources directory in there in which we have a development config, which sets a connection string and a HTTP port and an HTTP IP. And we have a production config, which may have those in slightly different ways. OK, so who does it like somewhat like that? Like, OK, so there are several things. I mean, it sort of works, like or it does work. I mean, you have a service up and running in production, right? So it's working, and you're doing your job, and you're getting paid. So you're probably it's probably working somewhat. But there's some things that I personally don't like about it that much. One is that let's look at this config object. It's a lazy val, right? So only when we ever use it, it will try to find a config file. So if we didn't provide one, or if we like misspelled our environment or something, it will already be somewhere deep in the service, or maybe not that deep, but in some level, and it will crash there. It's not like a type error or something. It's like it's a crash. Also, if you misspelled a key or have forgotten to give a key, you'll get like an error here where it's trying to read this. So I think what a lot of us do in order to make this a little bit fail a little bit earlier is instead of reading stuff as a string straight here, they do something like, okay, let's say HTTP host, and then in the config object, we do something like this, right? Who does that instead of what I've shown before in the config object? Okay, so it's still failing late though. It's still the same thing because it's lazy, right? Because we probably want to make it strict. We probably want to read it every time. So immediately when we start up, we immediately get the error. And this could be even worse. Let's say so there's another thing here. The HTTP server in one of the routes uses a database, right? And in the database, there is a query, like a client that reads something from the config, and then there is a query method, and this tries to execute the query. And otherwise, if there is a configuration value that says log the error, it logs the error. But when you then, while that happens, like when the system realizes, oh, it's not there, then it crashes, and you don't get the query that actually led to the crash. And you might not get any information because you messed it up. So it's much better if you're able to catch this like earlier, not only when the problem happens, right? So now we're moving all of them. Okay, let's do this. We're moving all of them into the config object. So we get this earlier failure. I guess Mongo log errors. And they're all vals, so they immediately when we create the config object or when we start up stuff fail. Okay, this one too, I guess. Okay, I think that's already an improvement, and that's how a lot of people here, I think, do it, so they get much earlier error messages. But now we actually want to write a test that tests our queries against an in-memory database. But we have hardwired our database against whatever the configuration is here, right? Here, the connection string. Oh, we haven't even pulled that out yet. So if you do, if you test your database, you probably actually don't want to hardwire against the configuration. You probably end up, I don't know, making the database a case class, maybe taking the config as an argument or something. I guess you could do all the individual fields, or maybe we just do, maybe we just turn our configuration into a case class. So now we can pass it in. I mean, we still have to change this. We can do, okay, let's say we have a case class, config, and then move this down here. What are the types here? That's a string, I guess. Oh, that probably needs to be here. But this is a string, and this is a Boolean, an int, a string. Oh yeah, and that stuff we actually need to. So I guess let's say we have a val default or something, which is the config, an instance of the config objects. Now there's a lot of names config here, but let's roll with it for now. Okay, we want to probably move all of this here. I hope I got the order right. Probably not. Another part where stuff can fail, but host connection port log errors looks good. Okay, so now we've put into this class, and now we can pass the class into the database. We could have also like restricted it down so we only pass the fields, but sometimes there's several things and we would just want to pass this around. Okay. So far so good. Now we have it parameterized. Now we can fail early. We can pass it around. But from what we have here, it's a very small step to doing something slightly different. We're using this dispatching mechanism here basically to decide which configuration to load, right? So we match on a system, an environment variable, and then we use that to load some file from disk. What if we use a built-in dispatching mechanism of the JVM instead of basically implementing our own? What if we say, hey, we have a, let's say we have an object, environment config. Oh, actually, let's go one step slower. Now that we have this here, we could also say, okay, we have this environment. If it is development, we just, I guess it's, yeah, here, haha. We want to make the config different depending on the environment. If the environment is development, we'll just create a config object that has these things in there. We didn't even have the log arrow key, so it would have actually failed when trying to log the arrow. I guess probably it's good to what's it called? I guess this is connection strings in the end, HTTP port. Okay. I guess we need the so now, and let's look here. Okay, so this is, I don't know, 10.0.0.8, and this is, I don't know, in production, maybe we want to bind to the public interface, and the port is maybe different. And we probably want to log errors, maybe log errors in production, but not in development or something. Yeah, so now this was like a fairly smallish change compared to what we did before, but now we don't need this library anymore. And we even get warnings at compile time if something wasn't provided. We can also put default values. And it's kind of, we have a single place where people can figure out what the configuration values are, and they can read it in the Scala format that they usually know. Okay, so we got rid of our configuration library, and because we already have a parser, the Scala parser, we already have a language to express key value bindings, case classes in Scala. But we can go one step further. The dispatching mechanism I talked about earlier, there is one built in the JVM. So instead of basically doing this, we can say, hey, why don't we have one object production config, and why one object development config. And we just take that stuff and put it here. And now, well, I mean, right now we would have to do the same thing, right? That's because we statically, like we kind of look up this configuration from here, for example. Well, I guess this would be default now, right? Or in the database, I guess we have to pass that in, which I didn't do yet. So in the HTTP server, now when we create the database, we'll have to some way create the database. And we have to get the config from somewhere, so I guess the HTTP server also has to take the config. So now it can also take, it's also parameterized now, so we can also run test versions of that if we want. So now basically picking the configuration went all the way into our main method, where I guess now we have to say here, well, config.default. I guess that's the one, because that's the thing that dispatches between our two environments. But if we're at that point, why don't we just create two main methods? One production main and one development main. And then we can get rid of all of this. And we just once start it up with the development config and once with the production config. And now we have the JVM itself, the JDK itself, or Java, I guess, the launcher to kind of help us decide which configuration we want to do. And there's another thing which gets simpler. So this is already satisfying me. So now it's all Scala. It's all parameterized. I can use different configuration for testing. I don't have to write my own like environment variable or something. I can just provide the class that I want to run in production or in development or testing. Or we have like in the latest project I work on, we have like four different of these runners. One for staging, one for production, one for testing, and one for development. And testing meaning when the unit tests actually run. So we have some in-memory stuff going on there. Right, and then a smaller change which you can do, which is just a convenience thing. Often this wiring here is almost the same in all the environments. It's slightly different in the project I'm on right now, because in production and staging, we want to really spin up the server with the real routes and all this stuff. But in development or in testing in particular, we spin it up with a mocked backend. So you kind of configure it slightly differently. But most of the code is the same. So you could just say something like, well, why don't we move this into the configuration? Yeah, what is it? And now our dispatching code, yeah, looks like this. And now configuration suddenly became something that's like the configuration of a car. The configuration of a car is not just how you turn the knobs, but really how all the parts are assembled together, right? So your configuration is really how the fundamental modules of the application are wired together, plus the knob settings. This is, I mean, you don't have to get all that far, but there's a certain convenience in doing it this way. And now you don't need a library, and it's all type safe, and you get type errors, and it doesn't even start up when it's wrong. Yeah, so that's how I like to do configuration. And that was the first topic. Let's get to the second one. Oh yeah, there's a question. Right, so the question is, what about like the non-Scala developers in your company who might also have to change this configuration, like people in ops or. Right, so there are trade-offs, and you might not be able to do that in every setting. You might also not be able to do that when you integrate different languages that have to read, like when you have a Python application that they may have to read stuff differently. I did write a blog post about this topic as well, which also kind of faces some of these different trade-offs against each other. Sometimes, for example, if you run in a cluster and that cluster provides you the port that you have to bind to, you can also not just hard code that in Scala. You can only hard code the things you know, but then you can limit the dynamic reading of config things to only the things that really are dynamic. But yes, in a language, in a situation where you have different people and non-Scala developers having to change the configuration, you might not get away with this, or different languages, yeah. So there's a, yeah, you could check out this blog post. That's my handle on Medium, and this explains it in the code examples, and also goes into the thing how you can still, even if you don't know all the stuff at compile time, but you can still write it in Scala. Basically, you can just bind jars together later, which is also a way to add configuration. OK. Yes, another question. The question was, isn't it better to use the system properties, the -d thing, instead of the environment variables? I don't know, does it make a difference? It's like some way to pass things, like, I don't know. I see us using system properties sometimes and environment variables sometimes. I guess when you're running on something like Circle generally provides stuff as environment variables. You have to read it from there. But then, yes. Sorry, when you?
If you have things like API keys or like secret keys, encryption keys, and stuff like that.
Yes. If you have secret credentials or something, you don't want to hard code them in your code. But then you can do the same thing and really just read only the things that you need to dynamically load from other stuff in that way, and not load all the other stuff which is fixed. Because you usually know, at least for your testing environment, all the values, and you can just store them there. And then for production problem, maybe you know even the IPs of your database and all this, and then it's easier and safer. OK, let's get into another topic which I personally find really exciting, also because I'm working on CBT, and CBT is something that kind of encourages you to do more automation for around your project, meaning build like basically what you classically do with bash scripts, but do it in Scala. And one thing you do a lot from bash scripts is you call out processes, right? And you conveniently pipe them into each other and all this. And this is really something where you can do this in Scala, but there's a certain overhead, and people often shy away from it. But it would be really nice if we could make this like very convenient and type-safe at the same time. So I kind of want to get into a way of doing this. So let's scratch that, and let's delete all these other files here. OK, starting fresh here. So let's just create a main method so we have something to work with, because this time we'll actually execute things. So let's say we want to invoke something like Git. Ideally, the way I would like to invoke something like Git for a little script that I write would be something like this: Git, I don't know, Git, maybe git.status. And then, or I guess maybe like this: quiet equals true, exit code equals true, or something. So I can check on my CI, for example, that after I run my code formatter, it didn't actually change anything, meaning my people have, like the people who committed code have properly formatted their code. So that's something you may want to run. And so how can we make this work? So it would be something like this, right? We do object Git, and in object Git we have it, let's say, a def status, and then status has quiet, which is a Boolean. Exit code, it's also a Boolean. It's just I think that's just a Git flag that tells Git to produce an exit code that's representing, I might be wrong, but we'll see in a second. OK, yeah, I guess the default should be false. OK, and now, in order to do something, this actually needs to do something. And one thing that the JVM offers us to do it, and we're going the slow, inconvenient way first, and then we'll basically get to how can we do this, apply this basically across to any command that we want in a nice way. So, OK, what would we do here? We would do Git status. I guess -- quiet -- exit, is that it? And then I guess it's, we have to provide a directory, I think. Let's just use this directory for now. dot start dot wait for. Oh, and inherit IO, which basically binds the input-output of this process to our current Java process, which means we'll see it in the shell when we invoke it. So let's just run this and see if this at least shows us. Actually, I probably don't want to run quiet, right? I guess we can do this, but we want to see some output. Okay, let's run this first. cbt direct run. We have to use this direct thing here, so we can. Okay, let's see what's happening here. No main class found. Oh, we have to go into app, I think. Yeah. And there's a type error. Okay, I can't close this. Sorry?
You're not passing quiet, I guess, to the process builder. Yeah, you're hard coding.
Oh yeah, I'm hard coding that it is quiet. That is true. I should do something like yeah, it gets like if you want to do this in like kind of extensive way, then it gets annoying quickly, right? There's a lot of boilerplate to write for one command. Okay, exit code. That it? Let's see. Doesn't find file in process builder. Oh, okay. We have to do this thing, so we pass them as the individual things for the var args, and we have to import java.io.file. Okay, let's see. I guess we got git status a bit wrong. What is it? Git help status? Is there no queue? Oh, it's diff, I guess, right? Let's do diff instead. Exit. Exit code. Okay, let's see. Okay, it didn't show anything. Because did we do quiet? No, let's do this as false as well. Yeah, let's print the parts and see. Maybe git diff isn't returning anything. Oh, that's true. Let's add something then. Let's add this one. Is git diff returning something now? No. Oh, but now we can change this. How about this? Yay! Okay, let's rerun this. Okay, there we go. Okay, now we have managed to call our process. Nice. Okay, fine. So basically, following this pattern, we could like slowly but surely implement type-safe wrappers around all our system processes and all their features and give us a type-safe API. But obviously that's a lot of work, and that's also a lot of work to get right, and that's usually something we wouldn't do as a one-off. As a one-off, we probably would just call process builder, or we would do the one-off in bash because it's more convenient in the moment. And right, so as a one-off, it's kind of annoying. But if we would either take away most of the work or make it much easier to do this, we might actually end up doing it, right? So that basically one approach, what you can do is code generation. You can generate this code for you, generate the Typesafe wrappers. And for code generation, we have two choices. We can either generate actual Scala code, or we can use macros. And in CBT, I've, for example, used code generation for one command that I wanted to call this way. If we look, whoa, there we go. So in CBT, there's one plugin but there's a library for ProGuard where I basically provide a Typesafe wrapper around ProGuard. It's in the CBT independent. But because ProGuard has only this main method, how to invoke it, there is some internal Java classes, but they don't really correspond to this. They're not documented. But ProGuard has this really nice reference sheet on their website that basically says all the things you can do with the runner and all the types you can it's even the types of what they are, right? So what I ended up doing for CBT is I wrote a little script that downloads this reference card, parses a bit of HTML out, then creates this file, which is now a typed wrapper, and including documentation from the ref card around. And it's not that, in the end, it's not that hard to do. I mean, it's still a little bit of work as a one-off, but if we do this for wget and a bunch of other commands and grep and a few, and then, I mean.
For all the Unix commands. Yeah.
Sorry?
We can parse commands.
Yeah, exactly. We can parse man files as well. So we should just be able to generate these wrappers fairly easily. Then at least we have a way to call one command. And OK, but often we chain them in bash, right? So that's something I'll get into in a minute, because we want to pipe things. Otherwise, we'll probably. OK, but this is one thing you can do. But I guess it requires a little bit of build setup, and builds are a topic of its own sometimes, right? So, right, you can do this, but maybe not everybody has the dedication, or maybe the tool you want to call isn't written this way. So an alternative approach would be macros. And what I've basically written is a macro. Where do we have this? Here. No. One more here. A macro that you put somewhere. It's called capture, if I'm not mistaken. Yes. And it will look at the next outer method and just give us all the information about this method as a data structure we can process. So if we do this here, we can say, let's just print ln this for now. So capture will look at the next method definition, which is this thing, right? And then just get information about this. And now the only thing we're doing with this is printing it. Let's do that. Let's see what comes out. Let's get rid of these debug statements. Capture not found. OK, we need to import it, I guess. Import helpers. .capture. Package help us capture not a value. Oh, capture. OK, fine. Yeah, for some reason, this thing currently needs a return type. In this case, it's unit because we just print ln, right? OK. OK, so now we got this data structure. It's just case classes, which tell us, hey, the method we're in is diff. There's an argument quiet. And actually, in the current call, it's been set to false. There's another argument exit code. And in the call, it's been set to false as well. And now, we can go ahead and use this. So we can say, hey, we want to call capture.name here. Actually, this is diff, so we want this, right? It's still Git. And I guess, let's see. And then we take all the take the, what is it called? It's the args, I guess, arguments. Here, case class args. Okay, we take the args in there. And each arg has a value. Actually, let's pattern match this right here. Argument, and it has, I think, some annotations which we are not using right now. It has a name, and it has, let's say, it's a Boolean that's true. And if it is this, then we're adding this to our list. Otherwise, if it's, I guess if it's anything else, for now we're adding nothing. Well, flat map. I guess this doesn't work. Let's see if this works. Because exit code is with a dash. We could go ahead and even do like, I guess, camel case to non-camel case mapping here. But we're slowly developing ourselves into like an abstraction of this, where by just providing different signatures here, we now have type-safe interfaces against different commands. And we're just on the way, halfway there to basically abstract out, right? Let's see if this already works for the git diff only, right? Exit code, okay, that's not, okay, this is exit code now. Ah. Oh yeah, it's these dead keys. Argument, I guess we need to import all of this stuff here. Okay, so that worked, and we have a lot more changes too now. So now we kind of extracted this stuff from here, right? And now we can go one step further. We can just say, okay, let's do that for multiple git commands. Let's get the status command in here as well. Let's take all this stuff here. Whoa. And extract this into we just call this staff to process, which takes a signature and does this. I guess it's to git. And now we're just calling to git here with capture. And then we call to git here with capture as well. Okay, let's see if that works.
Let's see close brace on to get.
A closing brace. Okay, fine. Let's see. To get not found. I guess we need to import lib. Recursive method to get. Oh, I see. We need the signature. Yeah. And oh, we need the return type. And I guess it's also unit. Is it? Yeah. Maybe not, but. Okay, so now we are able to call both of those commands. We can generalize it one further where we're saying, okay, let's actually make it to process and just get rid of the git stuff. So let's not do git for now. Let's do something like def cat equals to process of capture and def grab to process of capture, and grab, I guess, gets a pattern, which is a string. And then do you want to do echo as well? Def echo takes a string. Okay, and now let's just try echo for now. I guess we need to support strings here as well now, right? And if it is a string, let's say we're just passing it through. Not found to process because it's in the lib. Okay, let's just move it all in the same class. And the return types, sure. Okay, so echo test worked. So now the really cool thing would be, can we pipe these things, right? And I only have a few minutes left, but I'll be able to get this to work, because you can pipe stuff on the JVM. So one thing I did, I implemented a pipe extension method for process builder and for sequence of process builder. So you can just pipe a bunch of process builders and you'll build up a sequence. Now you have a sequence of process builders, right? And then this exit method, exec, which takes a sequence of process builders, and it will set all of them to, I guess, put the standard arrow just straight out, but turn the input and output to pipes. And then for the first one, I say the input is attached to my Java process, and for the last one, I'll say it's also attached to the Java process. And for all the other ones in a sliding window of 2, I'm creating threads that pipe from one to the other. So now I've chained them all together. And then there's this thing here, but it's, I mean, it goes down to the JDK fundamentals like threads and streams and all this. But you can write this once and then forget about it and just be able to pipe stuff into each other. I mean, SPT has something like this as well, which has made it into a standard library. And if we combine basically this piping mechanism with the type safety of commands, then it becomes really nice, because now we can do something like, okay, now this stuff doesn't actually run these things. It just returns the process builders. And now we can do something like pipe this into cat and pipe this into grab. And we just want the things with the A in there. And that probably doesn't work on first run, but we'll see. Exec not found. OK, I guess I got to import pipe. Yeah, and now we're piping things in a Scala main method in a type-safe way and have a nice way to embed our own commands into this step by step. And so I have a prototype of the macro and these functions kind of as a library, which I'm still working on, but I'm planning to release that as part of CBT, but as a self-contained library that can be used outside of it as well, just so we can like do safe and nice bash scripting. Because a year ago I made a resolution that I'm not writing bash scripts anymore. It worked. All right, that's it. Oh, one more thing, very quickly. So the last thing I wanted to show, which I haven't gotten to, we're calling out to processes, right? We can also call into Scala as a process. So something that CBT does, where you can just call methods, but also other things like Ammonite is where you basically have a way to call Scala methods and even pass arguments. So you're kind of reusing your type signatures to automatically generate a command line interface so you don't have to write a command line parser, which is kind of the flip side of what we've been doing right now. It's also something I think we should be just doing and like just give away, just write a library that does this and then solve it once and for all. And like have seamless interoperability between all these untyped worlds, and you could do the exact same thing for REST services. I mean, with less control over HTTP, but most of the time we don't need it either. So we have fluent integration between the untyped worlds and the typed world in Scala. Typesafe world. Thanks. Join us in New York and rate the session. And that's.
I think you have some questions.
Oh, yeah. Do we still have questions? Yeah.
Hey, it looks like we're moving really fast to Scala OS, and in which decade do you expect it to happen?
So we should?
We're moving to Scala OS, and like, in which decade do you expect, how soon you're expecting this to happen?
How soon I expect? I mean, I'll put this into like our scripts as soon as I can. I don't know. I'll make it available, and then we can just see if it's working out for people or not.
We can do drivers in the implementation.
Sorry? Yeah? Oh, drivers, yeah. Scala native. Maybe, I don't know. Rust looked pretty good too, though.
How does that relate to like the Ammonite where you can type stuff and these nice little...
Right. It's the same idea, basically. So what Howie did is that he implemented commands that are similar to the shell commands in Scala. This just really literally hooks you up to the actual shell commands, right? So it's two approaches around the same thing. This one makes it like very nice to just make it extensible so you don't have to like rely on somebody having implemented it already. That's kind of my, and in the end you just call so many shell commands for your like scripts and builds and CI and all this. Yeah.
Just on that also means then that you're depending on your environment, right? You have to run on especially.
Yes, now your bash scripts are depending on your environment too. And with this thing, you could actually go ahead and provide different variants for a BSD grep and a Unix grep and or Linux grep, and then type check your, maybe even abstract that out. Yeah. No, in Ammonite ops you also have type safety. Right. I mean, the thing is, the piping stuff between these commands isn't exactly type safe either because it's just string streams, right? And we're working with those. But at least the flags you can set on these things don't randomly break, and you can like make nice conditionals around them, which you sometimes need in scripts. But Ammonite is also just Scala methods with similar signatures to the one I showed here. So. Ammonite ops is platform independent because it is written in Scala, but I mean only the stuff that's supported. Yeah, so that's the trade-off, I guess, between the two. Yeah.
This was really cool. I love the demo. So you started initially with the kind of build your own type safety, and then the end was a very, very impressive demo, but also there was a lot of magic hidden in that capture method, right? And those other things you weren't showing. So I'm wondering, is the takeaway inspiration for me to be writing my own capture, or are you trying to get users of your library?
Actually, I'll just put the capture method. I guess capture is actually, if you want to like play with macros, that's kind of a nice start because it doesn't touch a lot of macro features, but does get you into the AST a little bit, where you have to think about literals and think about some names and annotations and stuff like this. But ideally, we would just make this available once, so people only have to think about this and get all the information out of it, and you don't have to write your own macro. And you don't really have to use a macro. Like, the macro is just the ad hoc thing that allows you to quickly type safe the commands you have at hand because nobody has done it yet. More sustainable is generating Scala code that just hard codes against, or wraps against these interfaces based from the man pages. I don't think the macro, like it's the more approach more in reach for things that aren't supported, but the code generation with text is actually the better approach. We just should put those wrappers online in some repository. So we have like not only TypeScript wrappers against JavaScript libraries. We have like Scala wrappers against system processes. Cool. Thank you very much.